You know, usually when we talk about maintaining massive, complex pieces of engineering, there's basically one universal rule.
Right, which is you protect the foundation at all costs.
Exactly. I mean, think of a skyscraper. You don't take a sledgehammer to the load-bearing pillars just to see what happens.
No, obviously not. You build thick walls, you set up security, you do absolutely everything in your power to keep the elements out.
Right, keep the structure stable. But then you step into the world of modern cloud architecture, and specifically the infrastructure behind the biggest streaming platform on the planet.
Yeah, where that fortress logic is just completely inverted.
It really is. We are looking at a system that maintains flawless video delivery to, 300 million people by deliberately unleashing malicious programs that assassinate its own servers on a Friday afternoon.
It's basically the absolute definition of counterintuitive engineering.
It is.
I mean, to achieve maximum reliability, they engineered a system of, well, constant, intentional destruction.
Which is wild. So welcome to this deep dive. Whether you are prepping for a tech meeting, navigating a major cloud transition at work, or you're just insanely curious about how your favorite shows actually reach your screen without buffering, this session is custom tailored for you.
Absolutely.
Today, we are opening up a really fascinating stack of sources. We've got Netflix's own tech blogs, AWS case studies, and some incredibly detailed internal architecture documentation.
Right, and our mission here is to unpack the counterintuitive story of how they stream all that video without owning a single physical server.
Yeah, which is a reality that not that long ago would have sounded like pure science fiction.
Oh, completely. Any serious IT professional would have laughed you out of the room.
Right. But to understand this massive AWS architecture, we can't just look at the code, right?
No, you really have to start with the disaster. You have to go back to a moment of sheer corporate trauma that forced them to reimagine enterprise tech entirely.
Okay, let's unpack this. Because the story doesn't actually start with streaming video, does it?
No, it starts with physical DVDs.
Right, those iconic red envelopes.
Exactly. So the factual core of this entire massive shift traces back to August 2008. At that point, Netflix's primary business was still logistics, shipping physical DVDs across the country.
Right.
And in August 2008, a single major database corruption in their physical data center caused their entire DVD shipping operation to go completely dark.
Completely dark. And I really want to emphasize the real-world scale of that based on the case studies.
Oh, it was massive.
Yeah, because we are so used to instant digital gratification now where, an outage means you can't load a web page for maybe 10 minutes.
Right, you just refresh the page.
Exactly. But a 3-day outage for a physical logistics company, that is a catastrophic hemorrhage.
It really is.
You've got millions of DVDs just sitting stagnant in warehouses, sorting facilities are at a total standstill.
Yeah, delivery trucks are grounded.
Customers are getting nothing. And it was all because of a single point of failure in one database, in one physical building.
Right. It was a literal nightmare scenario. I mean, it exposed the fatal flaw of the fortress mentality. If the wall breaches, the whole castle falls.
Yeah.
And that 3-day blackout, that was the catalyst for a paradigm-shifting reaction from CEO Reed Hastings.
He made a pretty radical vow after that, didn't he?
He did. After the dust settled, Hastings vowed that Netflix would never own infrastructure again. He decided to bet everything on Amazon Web Services, or AWS.
Which, looking back now from where we sit today, sounds so obvious. Like, sure, move to the cloud, everybody does it.
Right, it's the standard now.
But I was looking at the timeline and the documentation, and we really have to look at the context of 2008 to understand how wild this decision actually was.
Oh, that context is crucial. Because in 2008, AWS was barely 2 years old.
Wow, just 2 years.
Yeah. Most traditional enterprises, the big tech stalwarts running on IBM and Oracle, they completely dismissed AWS. They basically looked at the cloud as a mere toy.
Like a sandbox for a startup or a side project.
Exactly. But renting server space on a public network where you share underlying hardware with total strangers, that was not considered a viable or secure enterprise solution.
Especially not for a massive publicly traded corporation.
Right.
I mean, I have to push back on the sheer risk involved here. This is like deciding your house is too fragile because the roof leaked once, so you sell the property to go live permanently in a hotel that literally just opened yesterday.
Yeah, a hotel that hasn't even finished laying the carpets in the lobby.
Exactly. It sounds incredibly reckless from a business continuity standpoint.
And many people inside the company felt the exact same way. The internal resistance to this mandate was massive.
The sources mentioned that it was really polarizing.
Very polarizing. You had brilliant veteran engineers who literally quit over the decision.
Wait, really? Just walked out?
Yeah, they fundamentally believed you could not run a serious logistics and media business on rented servers. Servers that you couldn't physically touch, reboot, and control.
Wow. But a core group stayed?
They did.
And the ones who stayed had to buy into this unprecedented vision. They were tasked with building something that had never been built before, on a platform that was literally still being invented beneath their feet.
Right. But Hastings making a mandate, drawing a line in the sand, is one thing. Actually moving a massive operation to the cloud is another.
Because a mandate is just words.
Exactly. The execution is what we call the Great Migration.
And it was a marathon, not a sprint. According to the internal timelines, it took Netflix 7 grueling years to move completely to AWS.
7 years.
Yeah, 7 years, just to finally shut down their very last physical data center. That is an absolute eternity in the tech world.
Oh, entire companies are founded, scale, and go bankrupt in 7 years.
Right. So why did it take so long? Like, what were the hardest pieces to physically decouple and move?
Well, the 7-year timeline really comes down to the friction of legacy software. If you take a flawed, rigid system from a physical data center and just drop it into the cloud.
What the industry calls a lift and shift, right?
Exactly. If you do a lift and shift, you haven't actually solved anything. You just have a flawed, rigid system that you are now paying to run by the hour.
That makes sense.
Think of a traditional monolithic database, like a massive, intricate Swiss watch. Every single gear is deeply connected to every other gear.
So you can't just break it apart.
No, you can't. To utilize the cloud properly, they had to rewrite virtually every piece of software they owned from scratch.
Wow, so it would natively fit a distributed environment.
Right.
They were basically rebuilding the airplane while flying it, taking apart the Swiss watch while it's still ticking.
That's a perfect way to put it.
Yeah.
But beyond the technical hurdles, the case studies heavily emphasize the cultural friction,
Yeah, the psychological rewiring of the entire engineering team.
which was arguably the heaviest lift. It was a fundamental shift from a mindset of, we own our servers, we polish them, we fix them when they break.
Right, to we rent temporary compute power from Amazon and we assume it will all break constantly,
Wow.
which goes against literally every instinct a traditional engineer is taught in school.
Totally.
It really makes you marvel at the persistence required from the leadership to not just abandon the project halfway through.
Yeah, because over a 7-year migration, you're constantly hitting roadblocks.
There had to be moments where it was just easier to authorize buying a few physical server racks to solve a temporary problem.
Oh, I'm sure there were. But they held the line. And when that final data center was officially unplugged, what Netflix had built in its place was completely unlike traditional IT infrastructure.
It was an entirely new blueprint for scale.
Exactly. And that blueprint is what we really need to break down mechanically.
So let's actually dissect that blueprint.
Right.
Let's walk through this invisible megaplex they built because the sources lay out the Netflix AWS stack quite clearly.
Where should we start?
Let's start with the heavy lifting. How the massive video files actually get from their system to your television. The documentation points to something called CloudFront.
Right. CloudFront is AWS's Content Delivery Network, or CDN. Along with their own internal network, this is the main delivery mechanism.
And the architecture notes there are over 200 edge locations physically pushing video to every continent.
Yeah, 200 edge locations.
I really want to explain how this works mechanically because the physics of it are just fascinating.
Oh, for it.
So an edge location is basically a localized cache server geographically situated as close to the end user as possible.
Right.
When you press play on a 4K movie, those heavy data packets aren't traveling all the way from some central database in California.
No, that would take way too long.
Exactly. If you are watching in Tokyo, you are pulling that video file from an edge server right there in Tokyo.
What's fascinating here is that the architecture deliberately separates the heavy lifting from the smarts.
How do you mean?
Well, moving gigabytes of video over thousands of miles introduces latency. And latency is what you experience as buffering.
Right, the dreaded loading wheel.
Exactly. So by pushing copies of the video files to those 200 edge locations during off-peak hours, they basically eliminate the physical distance the data has to travel when you actually press play.
Okay, so CloudFront handles the dumb, heavy lifting of the video files, but what about all the smarts?
The smarts are a different story.
Yeah, like my personalized watch history or the algorithm telling me I might like a gritty Scandinavian crime drama because I watched one 3 years ago, or even just my billing info. Where does all of that live?
That brings us to DynamoDB. This is AWS's highly scalable, NoSQL database service.
Okay.
And according to the architecture docs, DynamoDB handles a staggering 1 trillion plus requests per day, just for Netflix's user data and recommendations.
Wait, 1 trillion requests a day?
Yeah, over 1 trillion.
I really want to ground that number for a second because a request isn't just you logging in.
No, not at all.
Every single time anyone, anywhere in the world, pauses a show, adds something to their list, or even just scrolls past a title on the home screen, the application sends a tiny heartbeat of data to DynamoDB to log that action.
Exactly. Every single micro interaction is a request. And DynamoDB absorbs that unimaginable volume because it spreads the data across thousands of underlying storage nodes.
Wow.
But the most critical part of this setup, the real reason they use DynamoDB for the smarts, is a concept called statelessness.
Ah, statelessness. I was reading through the AWS case studies, and this concept is really the key that unlocks the whole cloud philosophy.
It really is.
If the user data, like what I'm watching, my place in the video, my profile is securely stored in a database like DynamoDB, then the actual virtual servers running the Netflix application don't need to hold any personal memory of me.
Right, they don't remember you at all. They're completely stateless.
Which means the application servers are just disposable.
Completely disposable. So if a server is processing your movie search and it suddenly, bursts into flames, no data is actually lost.
The system simply routes your search to an identical, newly spun up server.
Yep. And that new server just asks DynamoDB, hey, what was this user doing? And picks up right where the dead server left off.
That is brilliant. And that disposability is exactly what makes the next piece of the architecture possible, right?
Yeah.
Auto-stealing.
Exactly. Because traffic on a streaming service is incredibly volatile.
Right. Nobody is watching at 4 a.m. on a Tuesday, but 8:00 p.m. on a Friday, the whole world logs on simultaneously.
And auto-scaling is the mechanism that manages that massive volatility.
How does it handle it?
Well, it's a system that automatically launches thousands of new virtual servers to handle massive load spikes. And then, crucially, it quietly terminates them when the rush is over.
So the company isn't paying for compute power they aren't using.
Exactly. It's incredibly cost-effective.
But it's not magic, right? How does it actually know when to spin up more servers without a human engineer sitting there pulling a lever?
It relies on continuous metric monitoring. The system constantly watches the CPU utilization or the network traffic of the existing servers.
Okay.
And the engineers set a threshold. Let's say if the average CPU load hits 70%, that triggers an automated API call to AWS.
And AWS just provisions new servers.
Instantly. AWS provisions new virtual servers, the load balancer detects them, and it immediately begins routing the Friday night traffic to them.
It's like a system that breathes in and out, expanding and contracting based purely on mathematical demand.
That's a great way to visualize it.
So we have CloudFront delivering the video, DynamoDB holding the state and the data, and auto-scaling expanding the compute power.
Right, those are the core pillars.
But tying all of this complex logic together is the concept of microservices.
Oh yes, microservices.
The documentation mentions there are hundreds of independent services running constantly. And just to prevent anyone from feeling overwhelmed by the technical jargon here, I like to think of microservices like a massive restaurant kitchen.
Ooh, I like this. Walk us through the kitchen.
So in a traditional monolithic application, like the legacy systems they spent 7 years migrating away from the whole kitchen is basically one giant assembly line.
Right, everything is connected.
Yeah. If the guy making the soup trips and falls, the entire line stops. Nobody gets their steak, nobody gets their salad. The whole application just crashes.
Which is how most legacy systems fail.
Exactly. But a microservices architecture is like a massive restaurant kitchen where hundreds of chefs work in total isolation in their own enclosed booths.
Okay, I see where you're going.
You have a billing chef, a recommendation chef, a user authentication chef. If the soup station catches on fire, the salad station doesn't even notice. They just keep tossing salads.
The isolation is key there.
Yeah.
But how do they coordinate the meal if they're all in isolated booths?
They use standardized order tickets.
Right.
which is what we call APIs in software.
Right. Application programming interfaces.
Exactly. The waiter doesn't need to know how the soup is made or what language the chef speaks. They just drop a standard API ticket through the window and expect a bowl of soup in return.
That makes perfect sense.
So if the soup chef decides to completely change their recipe or upgrade their pots and pans tomorrow, the waiter's job doesn't change at all.
And in Netflix's architecture, that means you can deploy an update to the code for, say, the recommendation engine without ever touching the code that plays the video.
Right. Hundreds of small, independent teams can innovate and push updates daily without coordinating with each other.
Because the blast radius of any mistake is confined to one specific microservice.
But this introduces a terrifying new problem.
Oh, definitely.
When you have hundreds of independent microservices and you have auto-scaling spinning up thousands of disposable servers on a Friday night, the sheer number of moving parts means unexpected failures are statistically guaranteed.
Yeah. When your system is that complex, you literally cannot predict how it will fail. You can only assume that it will.
And as we talked about at the very beginning of the deep dive, instead of trying to build thicker walls to keep that failure out, Netflix decided to invite the failure inside the house.
And here's where it gets really interesting. They realized they couldn't just wait for a Friday night spike to find out which microservice would break first.
Right, you don't want to find out during peak hours.
No. So they invented chaos engineering.
Which has to be the most counterintuitive idea in the history of tech.
Without a doubt.
It is the practice of deliberately breaking your own infrastructure during normal business hours to find hidden weaknesses before those weaknesses manifest at 3 a.m. on a Sunday.
Exactly. And to do this, they built a specific legendary tool called Chaos Monkey.
Chaos Monkey. I just love that name.
The name perfectly describes its function. It is a script designed to randomly terminate live production servers.
Live server.
Yes, it mimics the chaos of a wild monkey running through a data center, just ripping out power cables at random to see what happens.
Okay, I have to play devil's advocate here. I am putting myself in the shoes of a traditional IT compliance manager reading this internal documentation for the first time. From a traditional risk perspective, running a script that intentionally destroys live production servers that are currently streaming video, to paying customers, that sounds like a fireable offense.
It really does.
How did they convince management that Chaos Monkey was a risk actually worth taking?
Well, you convince them by proving that the alternative, the 2008 three-day outage is much, much worse.
Right, you remind them of the trauma.
Exactly. And you prove the system works by controlling the variables. If we look at the specific lore from the sources, there's a really famous story of the first time Chaos Monkey was unleashed on a Friday afternoon.
Yes, the Friday run. The engineers are literally packing up their bags, getting ready to head home for the weekend.
They deliberately run this script that begins assassinating live servers.
Wait, why a Friday afternoon? How does anyone sleep at night?
Because they wanted to test the absolute limits of their auto-scaling and their microservices when the engineering team was actually awake.
Oh, that makes sense.
Yeah, they were caffeinated, at their desks, and ready to monitor the fallout. They wanted to prove that if a server died, the stateless architecture would actually work.
So they were watching to see if the load balancer would instantly notice the dead server.
Right. Route the customer to a healthy one and let auto-scaling spin up a replacement, all in a matter of milliseconds.
Without the customer at home ever seeing a buffering wheel on their television.
Exactly. And the test was a massive success.
Wow.
By forcing the failure in broad daylight, they proved the resilience of the architecture. They basically took away the fear of the 3.0 AM pager going off.
It's essentially building a digital immune system.
Yes.
You expose the body to a small controlled virus, the Chaos Monkey, so the system learns how to fight it off and heal itself automatically.
And this wild internal experiment didn't just keep Netflix online. It fundamentally changed how every other major tech company builds software today.
Which leads us perfectly into the wider impact. Because Netflix didn't keep this a secret to maintain some sort of competitive advantage, did they?
No, they blogged about it extensively. And they actually open sourced the tools for anyone to use.
So what did the rest of the industry actually learn from watching Netflix actively destroy its own servers?
Well, if we connect this to the bigger picture, it forced a massive conceptual shift across the entire software industry.
How so?
The legacy standard was building against failure. You spent millions trying to create perfect hardware that would never, ever die.
Right.
Netflix taught the industry to build F4R failure. You assume the underlying hardware is cheap, unreliable, and will die constantly.
So you design a decoupled, stateless software architecture that simply doesn't care when the hardware fails beneath it.
Exactly. And for you, our listener, if you are studying AWS services right now, or you're managing a tech stack at work, you are operating in the world Netflix helped create.
That's a great point.
The concepts we just discussed: auto-scaling groups, reacting to metrics, decoupled microservices, communicating via APIs,
Mm.
highly available databases like DynamoDB. These are no longer wild experiments.
They're the gold standards.
They are the absolute gold standards of the industry. Every modern, resilient app you use on your phone today was built on the architectural lessons learned from Chaos Monkey.
So what does this all mean for the end user? I have to ask the ultimate, slightly cheeky question that always comes up in these cloud case studies.
Let's hear it.
After all this brilliant engineering, after the trillion requests to DynamoDB and the edge networks and the immune system tested by monkeys, when I'm sitting on my couch on a Friday night and my streaming video suddenly stops and starts buffering, whose fault is it? Is it Netflix's code, or is AWS having an outage?
This raises a really important point about the limits of even the most perfect architecture.
Okay.
Because if we look strictly at the AWS stack we just discussed, the honest answer is it's almost certainly neither of them.
Wait, really? You're telling me the cloud never fails?
Oh, it fails constantly. But the architecture hides the failure.
Right, the statelessness.
Think about the mechanics. If auto-scaling is instantly replacing dead servers, and DynamoDB is managing the state flawlessly across a trillion requests.
And CloudFront has successfully pushed the video file to a physical edge server located practically down the street from my house.
Exactly. The bottleneck is rarely the AWS architecture.
So where is the point of failure?
It is almost always the final mile to your screen.
The final mile.
Yeah. It's your local internet service provider dropping packets due to neighborhood congestion. Or, it's the fact that your Wi-Fi router is hidden behind a thick brick wall in your kitchen.
Or someone else in my house is downloading a massive 100-gigabyte video game update at the exact same time I pressed play.
Exactly. The global megastructure worked perfectly to get the file to your city. The localized delivery inside your own living room is what failed.
That is absolutely wild to think about.
Isn't it?
The most robust, battle-tested cloud infrastructure in the world, capable of surviving a localized data center apocalypse, entirely defeated by my microwave interfering with my Wi-Fi signal.
The irony of modern technology: we solve the global problems only to be thwarted by the local ones.
Well, to wrap up our deep dive today, we've really journeyed through an incredible evolution. We started with a catastrophic, business-halting DVD outage in 2008. We moved through a grueling, psychologically taxing 7-year migration to the cloud.
Yeah.
And we arrived at a 300 million user megastructure, an invisible megaplex powered by stateless applications, independent microservices, and continuously tested by intentional chaos.
And as a takeaway for you listening, understanding the specific Netflix architecture really is the ultimate shortcut.
How do you mean?
Well, if you can grasp how auto-scaling, DynamoDB, and CloudFront work together to survive Chaos Monkey, you essentially understand the foundational mechanisms of all modern cloud computing.
That is incredibly empowering. I want to leave you with a final provocative thought to mull over as you go about your day.
Okay.
We've seen how Netflix achieved unprecedented industry-defining reliability. But they didn't do it by building thicker walls or hiding from risks.
No, they didn't.
They did it by continuously and intentionally attacking their own systems. So if a multi-billion-dollar tech giant gets stronger and more resilient by actively breaking its own foundations, what long-standing processes in your own work or even your own life might actually benefit from a little chaos monkey of their own?
Sometimes you really do have to invite the wrecking ball inside just to see how strong the house really is.
Thanks for joining us on this deep dive. We'll catch you next time.